Okay, everybody, we're going to try this again, and you are going to actually skip ahead in packet 4.3, and you're going to start on problem number 7 and work your way through problem 17 for today's homework in class. Whatever you don't get out in class today will be homework and due tomorrow, or excuse me, I guess it'll be due on Monday, and for the rest of the period you're going to be reading, silent reading for 25 minutes. So first of all we're doing with these problems is you're going to try and write an equation for the table of values. So we're going to use this example that came out of your packet as one of the examples and work through it. So this is a problem where you have W is the number of animals, wildebeest, and C is the cost of these animals. So for different numbers of wildebeest, they have different costs. So the first thing we need to do is determine which one is the input and which one is the output. And for this, the number of wildebeest will determine the cost. So the wildebeest will be the input and the cost will be the output. So we can start by just writing a simple blank equation with this and showing what we need to find still. So cost will equal, and we'll have a box here for the rate, and we'll have wildebeest there, and then we're going to add some initial value. So we're looking for a rate and our initial value for this one. So remember that our rate is going to be our change in y over our change in x. Our change in y over our change in x, or in other words, the change in our output over the change in our input. So let's take a look at how that looks on our table. Well, we can look at the fact that from 12 to 14, that's the change in our input, that's going to be a change of plus 2. And over the same place, going from 1,900 up to 2,200, that's a change of 300. So we can use that to actually tell us what our rate is. And from that we can say that our change in y, or change in our output, is 300. And our change in our input is 2, and that can be reduced down to 150 over 1, or simply 150. So that's going to be our rate. So that'll be nice, and we'll fit that right in there. And now all we need to do is figure out what our initial value is. Now there's two ways we can do this. First way is we can notice that all of our numbers up here for our input always are jumping up by 2. And it looks like our numbers for our output are always jumping up by 300 as we go across. So one way we can do this is we can simply work our way backwards as far as we need to go until we reach 0. Well, if we went backwards from 12, that would be 10, 8, 6, 4, 2. That seems like a lot to go backwards, and I don't know that I really want to count backwards that far by 300s. So what we can also do is we can simply use the information we have already in our equation to figure out our initial value, and it works like this. So let's fill in our rate first. So far we have C equals 150 W plus our initial value, which is what we're going to be looking for. So it would be nice if we knew some cost and some number of wildebeest for the problem. Well, it turns out we do. We know all of these. 12 wildebeest for $1,900, 14 of them for $2,200, 16 of them for $2,500. And we could use any of these. We could say use this as our W and this as our C, and then we could solve for our unknown. So it works like this. We'll say 16 here. Actually, you know what? Let's take the 20. I'm going to use 20 instead. Take the 20, and we're going to plug it in right there for W. And then we're going to take the 3,100 right here, and we'll plug it right in there for C. And then we'll fill in the rest of the equation. We'll put a B right there for our initial value. And now all I need to do is solve that equation right there. And then it just becomes a simple math problem. And we'll use our French bread model here and keep our equal signs lined up. 150 times 20, so 150 times 10 is 1,500, and double that. It's going to give us 3,000 plus b. And then all we simply need to do is solve that for b by subtracting 3,000 from both sides. Which will leave us with 100 equals b. And there's our initial value. So now that we know our initial value, we can simply write the rest of our equation and fill it all in. So c equals our rate, 150, times w plus 100, and that is our equation. So once again, let's take a look at what we did here to solve this. We started off by writing our equation and realizing that we needed to find our rate and our initial value, and that will be the case for all of the problems. And then you'll find the rate by using the change in y over the change in x. The change in y right here divided by the change in x right here. Remember, if this goes down, if the value goes from a higher number to a lower number, that will be a negative number. And then we simply plug that in to our equation. Actually plugged it in right here. And then we used two of the values from the table for our input and output, and then simply solved that for our initial value to give us our initial value, and then used that for our final equation. Go ahead and look back over any of this if you need to get some help and remind yourself what to do, and that will be what all the problems look like on today's work. There are going to be some problems where you may be able to work your way backwards, and it's going to be easier to get backwards to where the input is 0. Remember, if you're trying to find the initial value here, if the input is 0, you'll know what the output is going to be your initial value. So if you can work your way backwards till you get a 0 for the input, again from 12 you would go backwards to 10, 8, 6, 4, 2, 0, going backwards by 2's. Once that gets to 0, you would have the initial value. So for example, it would look something like this. So I might say 10, 8, 6, 4, 2, and 0. And then I could work my way backwards by 300s. And I will just do this without writing it down. 1900 minus 300 is 1600. Then minus 300 is 1300. Minus 300 is 1000. Minus 300 is 700. Minus 300 is 400. And minus 300 is 100. So when W is 0, C is indeed 100. And so that's another way you could do it. That's just kind of a long way of going about it compared to doing the equation.